right, so if I take, so I'm going to number these suckers. It's a really good idea. Keep yourself straight. So if I do 1 plus 2, what do I get? 3x. The y's cancel. Equals negative 6. I like it. So there's one better equation. Now I know the first two examples we've done, we kill the y. It's just a coincidence. You kill whatever is the easiest to kill, right? You kill the x's first, you kill the z's first, it don't matter. The easiest way to kill y again, what is that? Turn that stuff down. I can hear that.
It's not me.
I know it ain't. Alright, whatever it was is gone. Okay. So if you use these two make the most sense because their y pieces are already different signs. So if I take twice number 1, I'll get 2x minus 2y plus 4z equals negative 6. Is that cool?
Yep.
And if I write down below that, number 3, x plus 2y plus 3z equals 4. Now I now can kill y again. So now I get 3x plus 7z equals negative 2. This is a lot like the first one. Oh well. Now, did anybody do a different way? I think a few of you guys did this by negative 2.
How'd you get 2y?
I don't know. If you take number 1 and multiply by 2, you'll get 2x minus 2y plus 4z equals negative 6. Is that decent? What's up? Is that all right?
I don't know.
If I take the first equation
Okay.
and I multiply it by 2,
Why you multiply by 2?
why would I do that?
I don't know.
To cancel the y.
So again,
Oh, okay.
yeah. So the more you understand elimination with 2 variables, the easier this is going to be because it's the same idea just used more often, right? So it's all about having the correct coefficient. If I wanted 2 there, I double everything. That's the only legal way to get a 2 to be right there. You can't just write a 2 there. You've made a different equation. It's going to have different answers. So I doubled the first dude so that the 2y that shows up here would cancel with the 2y that's down there. So I killed y twice. I like it. So now I've got my, why did I put 3 there? Now I got my 5th equation. Now this feels exactly like the last problem, which kind of sucks, but oh well. Because now if I take this one, for example, and I multiply by what? So that the x's die. If I multiply this one by negative 1, you write that down here. So that would be negative 3x minus 3z equals 6. The x's die. So do you see how it's like you pick a letter, you kill it twice. Now you're left with 2 better equations. Between them, you do that again. You kill a letter. There were 3 letters to start with. If I kill one of them twice, now I've only got 2 letters. If I kill one of those, now I know the value of one of the variables. I can solve for it. So here I get 4z equals 4. Good job, Jeff. Divide by 4, I get z is 1. What happened? So here's this equation we just made, right? Here's this equation we made earlier, just multiplied by negative 1. Why? So that these 2 will die. Yeah. Now I can figure out what z is, because I killed the x, and z is the only variable left. So now I know z is 1. What's the letter I can get now? X. Now I can get x, because I can just go one step up, dominoes, and start to fall back. So I come back to this guy. So if I put z as 1, let me do this one. 3x, if I use this equation, 3x plus 7 times 1, because z is 1, equals negative 2. I get 3x plus 7, it's negative 2, subtract 7, 3x is negative 9, divided by 3, I get x is negative 3. Whew. Once you start getting letters, you start plugging them into the equation you just came from. Now I've got two letters. Where am I going to plug those in? Now I know x and z. Where am I going to plug those? Somebody out there's like, I'll tell you where to plug, John. Where do you plug those? I'll tell you where to plug all this shit. I'm going to plug it back into one of these. They're the only ones that got all three letters in them. So just use the first one again just because it's easy to write above it. X we figured out is -3. Don't know what y is. Z we figured out is 1. Let me see if you guys can handle this. Well, I mean, if you solve this, the 3's canceled. You guys see that? If you add 3 to both sides? And then if I add y, I get y equals 2. However you could solve that, you solve it.
Do X.
Say again?
Solve X.
We already had x, right? We figured out what z was. So then I fell back to one of these two equations. I just chose this one just because. Doesn't matter which one I choose because it's supposed to be where everything is the same. So if I plug it into either one of these, I get x is -3. Now I go all the way back to the beginning because that's the only thing that's got x, z, and y. So then I can figure out what y is. It is very much a puzzle. But the funny thing is, they all, well, most of them work the exact same way. You pick a letter, you kill it twice. Now you got two smaller, easier equations. You do just like chapter 4. You kill one of those letters, and then you know what the last letter is. Plug it in, plug those two in, you're done. It's always the same steps.
So it's just always going to be a combination of substitution and
Yes,
elimination?
totally. Yes. Okay. Thanks, man. Normally, I love it when people like set up camp outside the door and just have this loud conversation. I'm like, get the hell out of here. All right. Now, there are some weird things that can happen. If in the process of doing this, you get 0 equals 7, what does that always mean? If you get 0 equals 7 somewhere, what's it mean? What's the answer? No solution, because the answer is true when 0 is, okay, 0 is never 7, so there's no answer, there's no solution. So you will see that kind of thing. There are some, let me see, does this one have one of them? No. Shoot.
I think this one has no solution.
Yeah, but there, I was going to point out, let me see if one of these has what I was going to say. No, not really. Sometimes you'll notice if you add all 3, something would cancel. For example, if this was a negative a, do you see if you add all 3, the a's cancel? All right, so there's more flexibility than just straight up the steps I described. You can kind of examine what's going on and deal with what you see. So if you see like a variable that would die if you added all 3, do that. And then kill that variable again. That's beautiful. It's just like sitting there and like, kill me. Right? That's sad, but oh well. Yes?
Can we do number 4?
Say again?
Number 4?
Let's see. Let's take a look. So 4 is interesting, to say the least. What's weird about the first and the last equation? They're already missing variables, right? It should be easier because somebody's already like killed some variables, but they did it in a very disorganized way. So now, in this case, now watch what could happen. Do you see how x is related to z? Do you see how y is related to z? In fact, be more specific. Y equals what exactly? Solve for y. Solve for y. How do I solve for y? I subtract.
So y equals 2 minus z.
Yeah, subtract z. That's all I'm asking, right? So y equals 2 minus z. So I know x is negative z, and I know y is 2 minus z. Can I rewrite the middle dude now? So this one, there is a shortcut, because there's already some stuff that's been killed. How do I rewrite the middle dude? What's x?
Negative.
Negative z. What's y? 2 minus z. Do you see now how I'll have an equation that's got only z's in it? Thank you. I like it. So if you rewrite this, you'll get negative z, because that's what x is, plus 2 minus z, because that's what y is, equals 3 minus 2z. Now this is going to be a funky answer. I get 2 minus 2z equals 3 minus 2z. If I add 2z, what do I get? 2 equals 3. So what's the answer? No solution. I love it. You love when that shit happens early in a problem because you get stopped. If you get 2 equals 3 or 7 equals 9 or something that isn't true, the variable died completely. There's nothing left. There's only numbers and the answer is not true. There's no solution. You gotta love them. Don't let one of these guys survive, right? 2z minus 2z is 0.
Where would X go?
What do you mean? All right, no, you ready? What is x? What is x? So I can take x and replace it with. He's still there. He's still right there, right? All right, maybe. It's sort of like this. Well, no, I'm not going to tell you that story. I'm just going to tell you a story about how I got my nickname Sparky in grad school.
Please explain that.
I'm interested.
So I was working in the physics lab in grad school, and I had to set up this experiment that involved a large voltage.
No, no.
And Jeff was holding too many wires when they turned the damn thing on. You're like, all right, well, yeah. I had 40,000 volts go across my body. Right? I'm still waiting for the superpowers. I got nothing. Thankfully, if anybody has any idea about any voltage and stuff, anybody ever work with electricity at all? Anybody? It was current limited, which is good. Because 40,000 volts across human body, if it's not current limited, you're not going to have a good day, at least. Thankfully, it was current limited, which means I didn't have as much current go across me as it could have been. 40,000 volts is a decent amount of voltage. Voltage is like how big the pipe is. Current is how much water flows. So I had a big-ass pipe, so I had a potential of a lot of current, but it was current limited, so not as much current was flowing. But it was enough to knock me to the ground. Every time I came in that classroom after that, the students would all look at me, and I'd be like, look at the light bulb, you know, stuff. Anyway, so my point with that was, if I made a list and I said, who's going, Joe's going, Fred's going, Sparky's going, and somebody's like, where's Jeff? Well, that is Jeff, right? So where's X? That is X. That's X's freaking nickname. X is also known as negative Z, right? So that's all we're doing when we're substituting stuff in. There's a long way to go for that. It was, I don't know why that memory came back to me. All right. So if you want to be good at math, that's all you got to do. No, I'm joking. I was good at math before that.